All right, so let's jump in. So hi, everyone. Welcome to day 2 of the Wharton Annual Analytics Conference. My name is Rachel Dutcher, and I'm the Senior Associate Director of Corporate Engagement for Wharton Customer Analytics. Today, we have 2 technical workshops for you to attend. This is the first. It's sponsored by Microsoft Azure, called Marketing at Scale, how Microsoft uses the cloud and analytics to discover powerful insights. In the session today, you will learn about Azure and how the Microsoft marketing team turns ideas into solutions by leveraging the Azure products and services. You'll learn the basics of Azure Storage, Azure Synapse, and Azure Purview for data governance, as well as how to use those services to power your immediate BI and machine learning needs. So we encourage you to turn on your videos if you'd like, so we can have a really interactive session. You can also submit questions through the chat throughout this session, but there will be some designated time open for Q&A as well. This session is scheduled to end by 12 p.m. Eastern time. So without further ado, I'd like to introduce our workshop instructors, Zhijun, who's the Marketing Communication Manager at Microsoft, and Praveen, Palepu, who's the Director of Marketing Data Science, Marketing Operations, and Technology at Microsoft. So I'll turn it over to you, Praveen.
That's great. Thank you so much. Good morning, everyone. Thanks for attending our session. We greatly appreciate it. Your time is valuable. We'll make sure what we show you today is going to be very valuable for you as well. So before we start off with the technical workshop and hand it over to Zhijun, who is our data science lead in our marketing US commercial business team, I want to set a context a little bit more here. And I want to give you some executive overview on what we are doing here at Marketing and Microsoft. What is our goal? What is our mission? And also sort of slightly talk about, the digital transformation that's going on. I'm going to take maybe 10, 15 minutes to set the context. Then we'll start with the workshop. So the way we are going to conduct the workshop today is we're going to take you through some of the scenarios we are currently working on at Microsoft in marketing. So again, it's a really realistic scenarios that we are currently working on that Zhijun has built so we can sort of take you through. So this is the session today. You already heard of it. And I'm not going to waste the time here. And what I'm going to do is I'm going to start off here. So I love to start off with this quote from Satya. So Satya always says, everything is digitized. Marketing is being digitized, finance being digitized, every industry is being digitized. Again, if you think about the transformation that's going on in the industry, right? Every industry, every company is trying to become the technical company in a way, right? And if you kind of peel the onion, why that's happening, why every company is trying to become, the digital first company. So, we conducted a study recently with Forrester Research Group, and we commissioned them. They went over our customers, about 305 or so customers, our business decision makers, and they did a survey. So in the survey, what they found is 45% of the business decision makers, they're trying to improve customer experience. Customer experience is a priority. And they're also finding customer experience is a growth driver for the business outcome, right? And 42% of our business decision makers, their priority is growing revenue. So growing revenue through customer experience, growing revenue through optimizing operations has become really pivotal to companies' mission in a way, right? So if you really further dig into these numbers, if you look at the customer perspective of these companies, right, that our customers we talk to, 86% of the customer expectations have on the digital experiences, meaning the experience they get when they go into that company's applications or a website or products, or even marketing and sales experiences have significantly increased. 86% of the customers expect best possible experience for everything they interact with the company. Not just, again, the products or applications or websites, but also the both marketing and sales experiences. Then you can see other numbers here, right? 88% are focusing on acquiring and updating the technology and other numbers here. But also, if you look at the data side, the analytics side of it, that we found that about 90+% of the business decision makers, they think that the ML and AI will have a greater influence on the business outcome. So again, astoundingly, really, all these companies are focusing on customer experience. They think that ML and AI will have higher impact on their business outcome. So this is a data workshop. Why are we talking about customer experience? So again, to provide the best customer experience, we need to invest on the data and data platforms to personalize those customer experiences. Where do we get the feedback? Of course, you can go to customers and survey the customers, but also the best other way to get the feedback on how these customer experiences are working is using data to glean the insights and personalize experiences based on the data analytics, right? So good data provides good insights provides, the effective action. So it's kind of like a loop, right? So now at Microsoft in marketing, we have been working on this transformation of our technology for about last 6.5 to 7 years. So if you look at our marketing technology, so this is our marketing technology, right? Again, I'm not going into details of this technology, but one thing I want to highlight, I'll say maybe two things I want to highlight, is technology is critical to bring in good data. So when I say good data, the data that is interconnected, so that you can use for our machine learning analytical models, right? Without good data, there is no base for a good foundation for analytical insights. And the technology that we bring in, and I always tell my customers when I go to this set of talks, is technology should be interoperable. Anything you buy within your technology ecosystem should talk to other systems. They should connect. Otherwise, number one, there will be disconnected data. We talk about it. And number two, that creates unnecessary manual processes that it would decrease the efficiency, but also negatively impact our outcome, right? So any technology that we bring in should be interoperable, should work within your ecosystem. And now, if you look at our data estate, so this is our marketing technology, and then we take all the data into our big Azure data lake, and then we use Azure Databricks and Azure Synapse to sort of power our machine learning and AI capabilities to our marketeers and our sellers. So again, where are we going with our marketing data science, right? Marketing and sales data science. So, I always am a very firm believer that every data science team in any organization, big or small or medium, should have a vision and a goal. So we should go with a uber big goal and then take all the projects aligned to the uber goal and make sure every project we do is an action-based project, meaning you have clear activities and actions for our end users, in this case, our marketers and sellers would go and do, right? So our big goal is building a combined marketing and sales customer journey. Again, not a surprise, we're in the marketing and sales team. We want to make sure our marketing and sales work together very well, which we have been for the last 7 years. And we want to make sure when we are creating a marketing journey and promoting a marketing campaign, we want to precisely know when we want to invite our sellers to do a sales action, and vice versa. When our sellers going through our sales stage journey, we want to know precisely when we want to go and inject our marketing campaigns, our marketing events, marketing motions with the sales journey. So that's exactly what we're doing now. So we're investing a lot of our efforts into marketing data and gaining marketing data and marketing data insights. We have done a lot of work on it. I'll show you some of the projects we did. And now we are going and investing a lot of our time into sales data, right? So what does our sales journey look like? What are the sales investments? and what is the impact of sales investments in our outcomes. And then we want to bring the both data sets together and look at how we can build this combined journey based on seasonality and time series analysis and so on and so forth. And there are like several thoughts on we can sort of reverse this model, just go and analyze both marketing and sales data together, and then go and build the journey there, and then go into individual data sets. And we chose this way for a couple of reasons. Number one, we want to make sure we understand the data really, really well on both data sets. And number two, when you start taking a big data estate like marketing and sales, we have billions and billions of rows in our marketing and sales combined data set, and build the machine learning models like AI to create these journeys. But explainability of that journey to our sellers is a bit difficult, right? Again, we talk about AI and ML, and it's all machine learning based, and it's a black box and so on and so forth. But at the end of the day, you need to be able to explain to the users, this is a journey, this is what you get out of it when you execute this journey, and this is how we sort of, came up with these recommendations. Without that explainability, at least at a high level, the adoption will be less, and end of the day, we will have trouble in using this insight. So to this end, what we have done and what we're investing today. So if you look at our sales side of the fence, we have a sales daily recommender today, and this daily recommender provides the actions, the accounts that our sellers need to go after with the recommended actions on a daily basis. Again, doesn't mean that every day it changes, but on a daily basis, it will provide them in a dashboard. These are the accounts, these are the contacts, these are the actions they need to go after. We call them a daily recommender. And we have that for our small, medium businesses, as well as our enterprise, big, businesses. And then we have an AI bot that prioritizes marketing leads. If you think about the volume of the marketing leads we generate on a daily basis, it's pretty big. We have about 3,000 or so marketing leads we generate that are highly engaged marketing leads, are qualified marketing leads to our sellers. And of course, we don't have that much capacity to follow up with all those 3,000 to 4,000 leads every single day. So we deployed an AI bot in the middle. The AI bot actively emails those 3,000 to 4,000 customers. Sometimes it calls based on how it is set up. And based on the responses we receive from those calls or emails, the AI bot automatically prioritizes based on the customer interest and also the outcome that we are going for. And then, and those highly prioritized list of leads would go into our sales, and others will sort of, kind of go into the lesser priority or lower priority. If they have capacity, they would go reach. So that AI bot is really, really working very well for us. Again, we have all our sales goals that we set up today in our quotas and how much revenue we can make in any given year at the worldwide, not just the US, but across the world. It's all machine learning based. We use machine learning to set those goals, and we do that twice a year. We do at the end of course, beginning of June, because July 1st is our fiscal year, and then also at the December point. But now we are rethinking about doing it every quarter and potentially every month. So that's a machine learning thing. And also we're investing very heavily in proactive sales investments. We have about, in the US itself, we invest somewhere around $55 to $65 million on our customers, right? Either it is proof of concepts or pilots that we do with our products. Whether let's say for example you are going and saying you want to test Azure for your company. We go out there and work with you, and we invest some of our funds to sort of make sure to test the Azure for your company and make sure it works for you, right? So we are doing now proactive investments machine learning based analysis on which accounts we need to go after, and where we invest more money, how much lift we get to our Azure consumption, or our Office 365 revenue, or our Dynamics 365 revenue. So again, there's a lot of investment analysis going on that our team is doing. Same thing on the marketing side. In the marketing side, we are way more advanced, and we have now marketing customer journeys that we built over years based on machine learning. And also we have, of course, based on the customer journey, we have target accounts we want to go after. From marketing perspective, we want to go invest in. Like, for example, this summit is one of them, right? And and also which audiences we need to go after: the business decision makers, the developers, and all the technical IT audiences. Again, there's a lot going on, and we are looking at the sales data, we're looking at the marketing data, and now we will look at both together and start building this combined sales and marketing journey. So with that, I will hand it over to Zhijun, but I'll take a pause while Zhijun shares his screen and get ready if you have any questions for me. Zhijun, let's go ahead and share your screen and start getting ready. Do you have any questions?
Thank you, Praveen.
Yeah. If you can unmute, ask me questions, or you can put in a chat. I will answer those for you. Okay, go ahead and take it over, Zhijun.
All right, just give me 1 minute. So can you see my screen?
Yes, we can.
All right. Hello, everyone. I'm Zhijun, and I will walk you through the details and how we enable the BI and the AI in the marketing department. I will start with the data architecture and the marketing. Do not be afraid about all these things. I will walk you through all of them. For us, we will get the data from upstreams. We have Microsoft IT department who own all the marketing and sales data. And we are using Databricks right now. We pull all the data into Azure storage. And after that, we will normalize the data and massage the data and put that all in the Azure Synapse. So you can see here, the whole block is Azure Synapse. And on top of that, we will build some models. The first one is a tabular model, and this model will use to power the Power BI dashboard. And we also have some machine learning models we can use to get some insights, get some statistics, and I will walk you through how we do that as well. And this is the general thing we have. Let me start with the Azure Fundamentals. We are heavily used Azure, and Azure is a cloud platform for Microsoft. And it contains over 200 products, lots of services, and you can do almost everything, I'd like to say. You can set up web apps, you can set up a virtual machine, and you can also set up your private network. Yeah, lots of things, very cool stuff. To manage and see all your resources, you can check through the Azure portal. The Azure portal is a UI environment to build, manage, and monitor everything you set up in Azure. There's some functions under Azure portal I will walk you through shortly. There's some security control, and also you can leverage cloud share in the Azure portal. Another biggest item in the Azure is the security center. So we have lots of security related items which you can build on top of the services you have, and Azure will monitor all the things for you. Now I'm going to switch to the demo, how what the Azure looks like, and how you can open the cloud shell. So I'm going to start with the Azure portal. All you need to do is just open a browser like Microsoft Edge and put the portal azure.com. You will land on this page. The first thing I want to introduce to you is the hierarchy of the Azure. So Azure does have some levels. The topest level is the tenant, but it's called directory in this portal. As you can see, you can have multiple tenants, and the tenant is the group you belong to. One tenant can have multiple subscriptions, which is the second level. And you can have multiple subscriptions. Depending on your role, you may have the owner, and you may be the account admin, or you may be some resource access. This is reader access. And under the subscription, there's another level. It's called the resource group. And let me show you one resource group. And you can have multiple resource group. The difference between the resource group to subscription is usually used to manage the billing information. If you want to bill separately, you'd better use the subscription. Otherwise, you can put all the project-related items under the resource group. For example, for this demo purpose, I create a resource group, and it's called demo. And I can click on demo, you will see all the resources I created for this demo. And another big feature for the Azure is the security. So you can click on the security center and you will land it on the security. For me, I have lots of subscriptions, and each subscription, they can give me a security score related. And I also enable some insights by just build on this security center. And I have a Power BI dashboard which can show me what is the recommendations and what is the vulnerability scan results. Based on all these recommendations, I will get some alert on daily or weekly, and they will send me some recommendations how I can improve the security for my services. Like for virtual machine, they will tell me I should do the just-in-time enabled, and I should encrypt all my hard disk, and sometimes I should probably set up some IP firewall rules. All right, let's go back to the presentation. Now I'm going to talk about the data. And for this session, I will cover two things. One is the Azure storage, the data storage. Another one is the Azure Synapse for the relational database. First, the Azure storage. Azure storage is Microsoft cloud storage solution for the modern data. It can be a hybrid thing, which means you can have your virtual machine data, and you can also have the cloud data. and all can be consolidated as one central place. And we are using the Microsoft, we are using the Azure storage for the entire data solution, and we usually call the data lake. Among all the data we have in Microsoft, the big thing is Azure Blob. Since Blob is the objective storage solution for cloud, which means you can basically save all your files on the Azure Blob. No matter it's a CSV file or structured file like Parquet or Delta Lake, you can just store everything on the Blob. And there's tons of very useful tools you can use to connect the Blob file to control, manage the Blob file. You can use the Azure CLI, which is the Azure command line tool, which is very convenient. And you can also use Azure PowerShell. And sometimes you can, if you are Pythonian, you can use Azure Storage REST API. For the Blob file, even for Azure Storage, there's multiple ways you can secure your access. You can control through the Azure Active Directory, which is the very big items on Azure, or you can just use the SES, the shared access signatures, for some one-time, or if you want to share the access externally, you can use this. It's very convenient. I will show you how to do this. There's some external tools you can use to get control through the Azure storage files. It's called the Storage Explorer. And you can download this client software and install on your desktop. It will work just like a Resource Explorer. You can drag and drop files, and you can download, upload files through this client tool. All right, let's go back to the Azure storage. Take a look what we can do with the storage. This is resource group I have showed you. Here I want to cover two more things. One is the resource level access control. You click on this button and you will land on this page. All you need to do is click on the role assignments to check who has the access to your resources. There's multiple built-in roles. One is the owner. For example, I'm not here, but let me show you how to. You can add an owner to this. You first select the owner, and you can put your email address here, and it will show up. You can add multiple persons at one time. For example, then you can save. Now I'm an owner to this resource. And there's another role is called a contributor, which is the read and edit role to this resource. There's another one is called a reader, which is the lowest resource access role. And this role can only read the resources, as just like name mentioned. There's multiple types for the, it's called identity. One is user like me, is a person. Another one is you can have a group of person. You can create we call it a security group. And you can put some persons under this security group and assign the whole group person as the owner, contributor, or reader. And the third one is the app. You can build an application which is service principal, sometimes we call it. And you can grant the service principal to these resources. All right, this is the resource group, and let's take a look on the storage account. I already have this storage account open, and let's start with the overview, and this gives you some basic information about your storage account. By default, your access here is hot. There's another one is called cold. If you want to save some very big files, you can use code, and it will less expensive. It will cost less. And for each storage account, there's multiple data storage solutions. You can see here container, file shares, queue and tables, but the most useful one for us is the container. So on the container, you can build multiple container, and container is kind of like a folder you can use to save your files. I already created one. Let's create a data lake 3, and you can create. And let's take a look on data lake 2. I call it the data lake. This is the username. And this, you can upload the files. And I create a folder called Titanic, and I upload a CSV file called train and the test. And I can share this through SAS I mentioned earlier. Let's show you. For the shared SAS, you need a read list, these permissions, at least 2, and generate this SAS token. And you copy this. Then you can use this. You can copy this and send it to some person, and they can use this to access your data. One way to access the data is through the Azure Storage Explorer. This is the client software you can install on your desktop. It will be, sometimes you can use this to upload and download the files. Just show you one way to use this SAS. You click on this storage account. You can connect to this storage account. Now you select the storage account and select this SAS and just put here. I don't know what that means. Oh, this should be blob SAS. Do not worry about this resource credentials. I can just enter this credential and it will show me all my resources. But for now, I'm going to just show you how to use this one-time SES code to connect the resources. Here I'm in this blob container, and I can see the Titanic data. Now I can just download this data. Click download. It will pop up a folder. I can select my download folder, and it will use the Azure. Okay, apply. And it will use the Azure copy command to copy this data. So you can copy this Azure command if you want, and you can take a look. Oh, command. And the command will look like this. All right, this is blob SES. Another one is if you want to share the entire storage account to some person through the SES, you can also do the same thing. Here, I click on this SES, and you can see what I want to share. Now I want to just share the blob. Then I uncheck this file, queue, and tables. And I need to share the services, containers, and objects. And I will remove all these permissions, probably write permission, delete permission, just read and list. And you can control how long you want to share. If you want to just share one day, you can just like me, or 2 days, you can just add one more day and generate SES and connect Zhijun. And you will see this SES connection. And you can copy this, go back to here, and connect to Azure storage. Same thing. Oh, should this one. Since I already have one, so they add a new name for me. So now I can see the blob container. So if you remember, I just selected the blob here. So it just enable me the blob container. Not like the blob file here. Now I can see all the storage container under this blob, under this container. Another security access is the access keys. Here they have some built-in keys. So you can use this key to connect this storage account as well. Usually the access key used in some other Azure services, like I have Synapse, I can enable this in Synapse. And I also have Azure Machine Learning Studio. Then I can use this access key to connect this storage. And there's some other configurations, like how do you want to replicate your data? They have the local replication and the geo replication. Yeah, but you can select when you build the storage account. But for most of us, we only use the local replication, which means we only replicate the data in the same data center. We will not cross data centers to reduce the cost. Yeah, let's go back to the story. Now we can take a look at the Azure Synapse, the relational database solution. So Synapse previously is called the Azure Data Warehouse. Now it integrated Spark for the big data, also integrated the pipeline for data ETL. It contains multiple solutions, so it wrap everything and rename as Synapse. here is the diagram of what Azure Synapse can do. You can see Azure Synapse is built on Azure Data Lake storage generation tool. There's multiple storage. One is a storage generation tool, another one is generation 1, and there's another one called Azure Blob Storage. The other tool is still live, but we recommend you use the latest one, which is Azure Storage Generation 2. The previous demo I showed you is Generation 2. Here, all the Synapse is built on this storage tool, and it contains 2 runtimes. One is SQL, which you can build your SQL data warehouse on. Another one is Spark, which you can use that to run the big data. And there's also multiple solutions built in the Synapse. You can do the data integration, and you can manage your data, monitor data, and you can have some security control your data. Mainly, all the SQL function can be, you can leverage all the SQL Server actions in the Synapse. And just like this, you can have all your data ingested in Synapse, and you can have Azure Purview to do the data governance, to set up your data lineage. And you can plug into Azure Storage, Azure Machine Learning to get your insights. You can also plug into Power BI to get your BI insights. So the most important part is the SQL. In Synapse, there's 2 SQL models. One is the serverless, another one is dedicated. We are not using the serverless, but you can. It's always there, it's always live. But since we have the dedicated, I will show you how to do the dedicated resource model. And Synapse SQL is built on the Transact SQL, so it has the same language as the traditional on-prem SQL. All the data is mentioned is storage generation tool, and it's managed by Synapse. Once you build the workspace, you don't need to worry too much about how to communicate with the storage. It will all be transparent to you. There's multiple security as well. You can have your traditional username, password. Another one is you can have your Azure AD under the same tenant, and you can have the application identity as well. One big feature to me for Synapse is the external table, which is the poly-based enable feature. By using this external table, you can connect all the files saved on your different blob storage. Like you have different CSV file, unstructured, and you can connect that through the external table. Or you can have some Parquet or ORC. All this can be connected. It's a convenient feature. Let me go back to the solution. Close this one. And this is Synapse Workspace. As you can see here, all the play content will be depends on the resources. For a Synapse, they have some Synapse related content like the SQL Active Directory admin, which is only available under the Synapse resource. Access control is the same. It will be always available for all the resources. And they have two more things. One is SQL pool, another one is Apache Spark tools. Let's select the SQL pools, and you will see there's two modes. One is serverless, always on SQL. Another one is dedicated. You created one. I call it a SQL demo SQL pool, and you can create a new one. And you can select the performance level. This will directly be the compute you want to use for your Synapse data warehouse. And you can see the different price once you select the performance level. Since I already have this, let's go back to the overview. And let's open this Synapse Studio. Sometimes it's called the Synapse Studio, sometimes it's called the Synapse Workspace. It's all the same, just different name. And this is the workspace. Let's open this, and you can see there's some tabs. Let's click on the data tab. And I can see my database, the demo SQL pool database. And expand this, I can see the tables. And another one is external tables I mentioned based on the polybase. Let's expand the tables. I can see there's 3 tables, and then select the 3 dots. I can select some rows from the table. Now this is some result from the table, and I can quickly view what the data look like. This is one way, all through the web. Another way I already opened is you can have some different client software, like Azure Data Studio, and you can connect to the same Synapse SQL, and you can see the same database, the same table, and then now you can select the same rows to take a look. This time you will connect the Synapse through the Azure Data Studio, this software. And the data, you can take a look at the data. Another good feature is you can use this to build a notebook to have your query and the result in the same environment. And you can select, let's say, top 3. And this result will be in the same place. And then you can share your funding to other person, and they will see your query and the result. It's convenient. Okay, let's take a look at the second tab, develop. I already have some pre-written query here. We can create a schema, Titanic, or we can create a new schema called demo. And successfully, and now And this database, I create a new schema. It's called demo. Demo is here. See, Titanic is the previous one. And you can control your data access. For example, I can create a new user and grant this user's access to my table. I call it test2 and test.com. And I can create this user and grant the user access permission. Now let's test the user permission. Now I try to run as the user and see if I can select the data. Yeah, I can. So you see, I can select the row, and I can also, I'm just run as the test user, test2 user. The third one is create external tables. In order to create the external tables, you need to do multiple things. The first one is you need to create a master key in your database to encrypt all your credentials. The second one is you will need access account keys. Now I already have that. Let's go back to, I already closed that. If you remember, we have this access keys here, and you will need this key. This is the key. Then you also need an external data source to tell the Synapse external table where to fetch the data. Here is the external source, is the storage account generation tool and data lake container. So I also mentioned here, then you define the external file format, is a CSV file or TSV file or ORC file. So you mention here. The final part is you create the external table with the location, and this is relative location. You remember we have data lake, storage, container, and after that we have the Titanic and the train CSV file. And you can create the external table. Once you create the external table, you will be able to see that through your external table folder. The difference between this external table to this physical table is external table is just a reference. The data is not copied here. Once you update the file in the container, it will change immediately here. It's just a reference, no physical copy. And this table is a physical copy, and the data is sitting in the Synapse, and the Synapse is storage. So it's sit on the Synapse storage. This is sit in your storage. It's different. Third tab is the integrate. Integrate is the Azure Data Factory. Previously we call, or not previously, we still have a Data Factory, but it's integrated into the Synapse Workspace. And by using this, you can do the data ETL very convenient. For example, I want to copy the data from my storage into Synapse. Now I can do this. I just drag copy data, and I can define my source and my sink. I don't do this. I can just show you here. I define the source. My source is from the storage. Let's take a look. This is the source data. It's from my storage, and this is the file path. And I can define all this thing. And I can also define the destination. It's called the sink. And the destination is the Synapse. You can see I can mention the Synapse, and this is the Synapse table, Titanic train. And I can just click on the button import schema. It will build the mapping for me automatically. You see the column will align. After that, then I can just run this to copy the data from the source to destination. The process will show up here. It will take multiple seconds. Since this is a small table, okay, during the data copying, we can take a look at the fourth tab. It's called the monitor. For the monitor, it will track all the pipeline runs. There's two things. One is you can see the debug pipeline, which is for the developing or testing. Another one is scheduled one. I don't have any scheduled. Even for the last 7 days, I don't have any scheduled. But for the debug, I do have some. So you see today, I just run this pipeline and it succeed. And that means data is in the Synapse data warehouse. And the manager is the top thing. You can scale up your SQL pool. For example, the size is 100 is too small. You can scale up to 200, 300, probably 1,000 if you want. And you can add some linked services. For example, I link the demo data lake storage here. And you can have Azure Purview for your data governance. Azure Purview is on the account on the tenant level. I don't have the permission to set up an account. Microsoft already set up one for me, so I can use Microsoft one. And all the data, they will register, and they will, once registered in the Purview, you can see all the data lineage, where the data come from and where data flow into. If something updated in upstream, they will know, they will notice you because they know you are using their data. And the integration here, and also some security control. All right, let's go back to the presentation. After the data, now we can come to the machine learning. So what is the machine learning? Machine learning to me is based on all your data and to forecast the future behaviors, to see what is the trend in the future. It's all forecast. You don't know the things yet. It's the future. Azure Machine Learning is the one-stop shop for all the machine learning related work. mostly by using the Python. Use this Azure Machine Learning Studio, you can first leverage all your data. You can build your model, train your model, evaluate your model, and even deploy your model as the web services. There's multiple content. The one is compute instance, which means what is the resources, what is the how to say that, what calculation power you want to run your model. Sometimes the model is very big, data is very intense, it uses a lot of power to compute the result. So it all depends on the hardware. So you can control this compute. There's two compute resources. One is you can set up one instance. Another one is you can set up multiple nodes called a cluster. You can do both. And the data store, data set is a reference. Data store you can build multiple to connect to your storage resources or some external resources like on-prem SQL, like Azure Synapse, or some Azure storage generation tool. And the data set is a specific table or file on the storage on the data store. On top of this, you can build a Jupyter notebook to connect your data, to consume your data, and run some algorithms to get your insights. And everything can be done through the notebook. This one is the general recommendations workflow diagram. Here you can see the first thing is you set up some storage as a data lake. Since you will either belong to a company or you were under some common place, so most of the time you will have a data lake environment. Now you can create your account there and connect to that storage, and you will have all the data here, data lake, and you create a reference as a data store, and you create a specific data set, connect to each of these files or tables, and run all your machine learning model through the data set you created. Okay, so now we can go to the Azure Machine Learning. So if you have questions, you can just ask me. I know it's a lot of information. This is Azure Machine Learning Workspace. And there's multiple tabs. The Home tab is a general thing. You can just click on one of these and to get started, they will have some documentations. Let's start with the compute. This is I mentioned. The compute is the power of machine you want to set up to train your models. There's multiple configurations you can use. you can set up a CPU or GPU, or you can select the SKU based on your estimation. And you can set up a compute name, or like a compute DS2. Rolling dash allowed. Demo. And it will create a new compute environment for us. And the compute cluster is the same. Instead of create one, they will create multiple nodes here. You will see for my cluster, the minimum node is 0, which means if I'm not running any notebooks, I'm not using any resources, they will deallocate all the resources, and then they will not charge me. If I do have lots of jobs, they will go up to 4 nodes and do all the work parallelly for me. And each node is the standard DSV2 SKU. And each node will have 2 cores and 7 GB RAM memory. And then all the nodes will be the same. Once you set up the compute instance, you can create your data stores. I already created a bunch of data stores. Data store is a reference to the data sources. For this one, is a reference to the data storage. I call it a demo data lake. And this one is a reference to Azure Synapse, the SQL database. I call it demo Synapse DB. And you can create a new. Let's take a look at this one to the storage. It will show you what is the storage account name and what is the data file format container and URL. And take a look at the Synapse database. It will first show the server name and the database name. After the data store, let's take a look at the data set. As you see here, I have the data set from this Synapse SQL database from this data store. And you can have multiple versions. Now I have 11 versions. And you can go back to any type of version you want. Let's see, go back to version 6. And this will be your version 6. Let me show you. There's multiple ways to create a data set. You can create a data set from your data store through this web UI. Demo, I call it demo 1. There's 2 data types. One is tabular, another one is file. Tabular is a table-like data set. Once you create a tabular, the data set will look like a table. File is just a reference to the source files, and you cannot see the details because it's kind of wrapped as a file. Let's select the previous created data store. This time we want to get from the Azure SQL database. Select. And you put your query here. Let's just take the top 3. And since we select the tabular, so it's a table-like thing. And I can see all the columns and all the data, this top 3 data. And I can see all the tables, and I can define the column type as well. Now I confirm I created this data set. And I can also create a data set through the notebooks. Now I open the notebooks. Once you create a machine learning workspace, there's a sample for you to reference, and it will be convenient if you want to leverage some samples. You can just create just clone this into your personal folder. So sample, and another one is the files and your personal folder. See here, I have demo, test, tutorial. Let's just clone this, how to use Azure Machine Learning, and my personal folder. It will copy all the files under this folder into my personal folder. This folder is big. I didn't realize it's this big. All right. Now we have everything from that how to use Azure. And I can just open this markdown file to see what included in this folder, and I can open each subfolder readme, and they will have some sample. Then I can just follow those samples, open this Python notebook, Jupyter notebook, and take a look. This import all the libraries, and go to the workspace and connect to that workspace, and link the Synapse to Azure Machine Learning, and show the linked services, and lots more. Let's close all this. Let's open this register data set and see how we can register a new data set. Do not be afraid all the code here. It will be the common code. All you need to do is copy and paste. You don't need to change it. This one will list all the data stores and my machine learning workspace. For now, I have a bunch. I can see I have data lake, this data lake store, and I have Azure Synapse database store, and Azure Blob, and some default Azure file. Let's register the data set from the data store. First, I need to name this data store name. It's called a demo synapse database. And I need to define the workspace, which workspace I'm running. Right now, I'm running under my workspace. If you are using this UI, you don't need to mention what is the workspace. Otherwise, you will need to tell the notebook what is a workspace. You need to just 1 sec. You need to mention your subscription name, resource group name, workspace name. Then you need to get all the information here to get your workspace. Since I'm doing here, so I don't need to mention all of them. I just use this to get a workspace. Now I can get a data store from this workspace and data store. For Azure SQL, I need to mention about query. So I'm just selected here, and I define the data types. You don't need to define all the data types. You only need to define the data type you want to change. Now I can use this to get a data set. The final step is to use this data set variable to register this as the data set and here. So let's register data set as 2. Take a look. Yeah, I can see the data set from this data source, and I registered. So this one I registered through this web UI, and this one I registered from the code. All right, after that, now we can finally start our machine learning model to see how we can build a machine learning model to deal with the real problems. I'm using the data from Kaggle. It's Titanic survival data. It's a computation. They have the data set. They already split it as a train and a test, but I'm only going to use train today. I'm not going to use the test to submit the computation. And here is the data dictionary on this Titanic. They have the label is survived, yes or no. They have ticket class, P class, 3 classes. They have the sex, male or female, and they have age. They also have the sibling and the parents to see if this person is with a family or not. They have the ticket number. They have how much cost they spend. They have cabin, and they have the port of embarkation. So it's a lot of information. Let's see what we can get from this. The first thing is before we start machine learning, we want to know what is the problem we want to solve. Here I just list 2. You can list all the real problems you want to solve. My problem will be what women and children of first ticket classes more likely to be survived. The second one is if we know all the information beside the label, beside this survival, can we predict? That is also the computation. They have the test data, which doesn't contain the survival information, and they want us build a model to predict the survival. And based on the accuracy score, they will judge if our computation is a win or lost. Okay, now we have the problems. Let's load the data. So the data will come from our data set we just registered. I will do first, I will load the data. But instead of using data set, I want to transform that into a pandas data frame because I'm familiar with the data frame and I want to all the data frame leverage all the functionalities. Now the data is in data frame. And for the common machine learning process, we want to just follow the standard steps. The standard step will look like define a problem and explore what the data we have. When we explore the data, we can identify the data types, missing values, and outliers. And we can also do the feature engineering based on our understanding on the data. After that, we can build a model and visualize the model. Okay, first let's explore the data. Now this is the data. Well, we can see the data type. We know this is integer, 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 and object means string. And we have integer. And we can see how many rows we have, not non-rows. 891, but the age we are seeing not. That means there's some nulls in the age, and most of the null happen on the cabin column. Okay. Now we know age and the cabin has some missing values. Let's take a look. What is the numerical variables and what is the categorical variables? The reason we divided this into 2 groups because this 2 groups is very different. We want to separate them and apply different analysis. And let's take a look at the summary. This summary is my custom library. I put here. We can do the how many count and how many missing values and what is the mean median value and the standard deviation. And we can also take a look at the quantile, the 25%, 75%, to get the skewness and to get the outlier by using the quantile. I put all the things in the customer function. Now I can check on the numeric for this data frame. I mentioned there's 4 numerical, so I can see age. There's some missing value. This much has missed in the data, and now I can see the mean age is about 29. And this quantile is about 21 to 38. Based on these two, I can get the outlier lower and the outlier up. If the maximum number is out of this range, then I can identify there's some outliers. So our maximum is 80, is about is 64. So I can say, oh, this data has some outliers. Now let's take a look at the histogram on this numerical columns. The first one is age. I can see, oh, age is more like a bell curve. Is normal distributed, almost. And I can take a look on the how many siblings. Oh, the siblings is not like well distributed. Most of them is 0 and 1, 2. How many parents? Oh, parents 0, 1, 2. Is skewed. Skewed means data is most data. Ideally, the data should be normal distributed, but skew means the data, most of the data is happened on the right side. And let's take a look on the fare, the cost on the ticket. I can see lots of outliers here. Even the 500, 300, 200 is outlier based on the statistic. For the categorical features, most of the time we can do the distribution count. But for now, I'm just checking how many data is missing. I'm seeing there's 687 missing in the cabin column and 2 missing in the embarked column. Okay, I think we can do 2 variables data analysis. The previous step is to only on 1 columns. Now we can do two columns. For 2 columns analysis, I'm using the SweetViz library, and the SweetViz can generate me a HTML file, which I can see what is the data distributed to this survive labeled column. So let's take a look on the class. Now I can see for the first class, ticket class, the survival rate is 63%. The third one is only 24. So the ticket class does have a big impact on the survival rate. So that answer me my first question. Let's take a look on the sex. Women, yeah, the survival rate is higher than the men. And for this age group, they have all the age numbers. It's a continuous number, very granular. I cannot get the easy statistic on this. So later on, I will do some feature engineering to get a child, to create a new column called child to see the distribution to the survival rate. And the sibling, parent, and Kevin, they also tell you there's missing 77% data. All right. We can start a feature engineer now. The first one is let's fix all the missing data. For the age, I'm just using the median value or the mean value to fill the missing data. It's very based on the sex and the ticket class. And for some outlier, I just drop that outlier. I just drop the fair rate about 400. I just drop that column. Just drop that rows. And this is the child new feature. Based on the age, I just call it child if less than 12. You can define on yourself. And I will transform some categorical data into one hot encoding to transform that. For example, for the sex, I will, instead of just use one column, I will create another column, sex female and sex male, and just put 1 or 0 into each column. Similar thing for the embarked. There are 3 values in the embarked column, but I created 3 new columns here. So this is called one hot encoding. And this feature, this 6 our new features I created. And I also drop some IDs because passenger ID, name, ticket can be real ID like columns is unique on each row, doesn't have too much information to me. I drop them, and I also drop the fare. The reason is the fare is highly correlated to the ticket. So I can tell from this association correlation, you can see the fare is highly correlated to P class. We don't need the same information in the model, so I just drop that. You can keep it if you want to test. Now, once we finish this feature engineering, we can take a look on how the data look like by using the same SweetViz library. Now I have the child, so I can see if the child survival rate is higher than the adult or not. Yeah, it does has a good survival rate. Okay, we can start building the models. Now we have the train data, and I can just use the train data to build a model. First thing is the label column is survived, this column. Then I can split the data to train. The reason why we need to split the data is we want to test. Once we build a model, we want to use some small part of the data, that is 20% of the data, to test our model. Here I'm using a classification model. There's multiple models you can select, and the machine learning is algorithms. So different algorithm will give you different result. There's no limit on the algorithm you can select. For each algorithm, there's multiple parameters you need to configure. We call it a hyperparameter. And this is different on each algorithm. Okay, we define the random forest classifier as a model, and if we feed the data into the model, then we can just train the model and do the prediction. After that, we can test the accuracy. So here, my accuracy score is 82%. It's not bad. Yeah, so I'm happy with the data. Now I can visualize this. One common visualization we want to do is we want to understand which feature is most important. How did we do the prediction? So we usually will leverage the feature importance from the model. And so here I just bring the feature importance from model, and it will show me age is the most important, then the male, then female, then the ticket class. Right. So far, I have done the entire machine learning process. Now the following part will be, I want to register this into Azure Machine Learning, since this is nothing to do with the machine learning. I just use the compute. But the below thing, I want to leverage some functionalities on the machine learning. I will use a different model. It's a logistic regression. The concept is different to the classification. They can also do the categorical prediction, but it is based on the logistic concept. It will regress to a statistic calculation. So here I define the model and fit in the data, train the model, and do the prediction, and test the accuracy. I can see the logistic regression accuracy is 75%. I'm happy with this result. Then I can register this machine learning model. Once registered, the model will show up under this model. You can see I already have a bunch of machine model registered. This is different versions. And after register model, I can deploy this model as a web services. Again, if even you are seeing lots of code here, but all you need to do is just update some configurations. All other will be standard. So I register this model. I can mention some tags and descriptions. I get a model name because I may have multiple models here. Models here. So I want to deploy this model, not other models. So through this model name, I get the model. Then I can define my deployment name. So here I will use this Titanic Logistic Regression SVC-UUID phone numbers. And then I can just wait for deployment. Sometimes it may take 5 minutes. And once deployed, you will be able to see that through the endpoint. Here is the deployment model. After that, you can test your model since it will be a web services. You can test that through the normal RESTful API. One way is through the bash. So here I'm going to test through my Git bash. So I'm open the VS Code, and I can, once you install Git, you will be able to see the Git bash. Then I open a Git bash terminal, and I can use this to get a result. Yes, so this does work. I input the data here. This is all the features, and I post the data to this web services, and it return me back the result. One means it survived. And you can see the web services name and this RESTful API endpoint. Yeah, I think that's the whole thing I want to share. Do you have any questions?
If you have any questions, please let us know.
Yeah, let us know if you want to know more things.
If not, there are 2 links I posted in the chat window. One will take you through Azure Synapse virtual training. It's a 2-day training class that we offer. You can sign up, and one is coming soon. I guess it's next week. If you want to join that, please sign up. You can join. You will go even more detail into Azure Synapse. You will have a hands-on experience on how that works. And also we have another link that I posted for a Cloud Skills Challenge. You can sign up for that, and it will take you through, in a challenging way. It's like sort of like a game way to learn Azure Cloud. So you will earn points as you complete a task. You'll have a start date, end date for each challenge, and so on and so forth. So please go ahead and do that as well.
I have a question.
Yeah, go ahead.
Thank you so much for walking us through how it works and illustrating with an example. How do we know if, say, random forest is the best algorithm? Of course, we can try like different algorithms and see. But without having to do a lot of statistical analysis, is does Azure has some guidelines for the sample size, for model accuracy, so that, we know that it's not garbage in, garbage out, so to speak, for lack of a better way of saying it. Will Azure alert us, if the sample size is not enough? And secondly, does it always converge, or sometimes you have to tune the model? To what extent is it very turnkey?
Yeah. So the model tuning, the first model tuning is whole data engineering, right? You will start with the data. You may need to do some feature engineering first. Instead of using the total siblings and parents, you want to probably create a new column called family. You put a small family, medium family, and big family into a categorical number, and retrain the model to see the accuracy score. Another one is select the different algorithms, just like what we are doing here. Instead of using random forest, probably you can try some XGBoost model to see if you will have a higher score on different algorithms. The third one is tune your hyperparameter. Hyperparameter is different per algorithm, and it will be a very tedious process. That's the reason Azure Machine Learning came out. You can have all your feature, all your algorithms and hyperparameter put together and loop through all these combinations. You can build some great search and ask machine learning to loop through them and put everything and experiment. I didn't show that. And you can check the result. Yeah, basically.
All right. I have a follow-up question. Do you, or does the package give us guidelines for what to do with missing values or outliers? Do we ignore them, replace them with the imputed value? It's pretty common. So are there any guidelines or best practices for that?
There's no general guidelines. It will be based on your knowledge on the domain. For our marketing, I know how to do the missing data. Just impute with some medium values or just drop that. It's on domain knowledge. Azure Machine Learning cannot tell you. Maybe there's some guidelines, I don't know. I will explore that.
No, I explored, but yes, in the past, I've used the imputed value, either use the average value for the brand or for the SKU, for the region. Replace it with some kind of imputed value.
Yeah. For us, most of the time, we just ignore those data.
Okay. Yeah. How many years of historical data you think is good to have a good model?
It's based on your algorithm. For us, where most of the time we use the z-score normal distribution. So we will take at least 30 rows. Okay. If the data is less than 30 rows, we probably will just ignore that. We will not do analysis on that.
Okay.
Too small.
All our models, I think it's Reshma speaking, Reshma, sorry. We use 12 months of data. Okay. So we are rolling 12 months.
Okay. But let's say for areas where seasonality is a huge thing, we might need more years. Okay.
Yeah.
Again, I think when you're doing the analysis, you might consider 2 to 3 years of data. But once the model is complete, to learning process, we use last 12 months of data.
Okay, I see.
Yeah, right. So another concept is Sometimes we will use a cohort to analyze the data. Cohort means instead of you put everything into one bucket, you do a model. We will split that into multiple buckets. For each bucket, we call the cohort. We just, for example, for our customer, we want to treat customer differently. Some big revenue customer, we call it enterprise, we build a model. Small company, we call the SMB, we build a model. So two different models will have different prediction.
Yeah.
That will increase the accuracy a little bit.
Okay. One last question, if I may.
Yeah.
Are there some guidelines to decide on the granularity of the model? As in, the example you walked through, you're trying to determine the survival rate on a per passenger basis. But then you can say, based on ticket type, or based on the port that they onboarded. Like, we want to be as granular as possible, but we also want it to be actionable. So how do you think about that?
It depends on the data you have. For us, there's so many data for the marketing. We just selected the most important one. For example, for our events, there's so many rich features, but for the most of the time, we just collect the event type as the big feature and analyze on that. We may be able to go, go ahead, Praveen.
Completely your thought, Zhijun.
We may be able to go deeper to the event channel. Is it channel on Facebook or channel on what else? Twitter. But most of the time we just go to the event type.
So again, when you're working in a big organization like ours, right? So we have core goals that we want to go achieve. Like, for example, by industry, we have core industries we want to go after. And for several industries and for our segments, Zhijun explained, enterprise, which are big, large customers, typically $2 billion plus revenue from them. And then we have medium and small. We have different KPIs for each of the segments, right? But a common KPI across all of the Azure consumption. Consumption is a huge play for us. So that's our first goal. So we want to see what programs will increase our consumption, right? And then we will consider our key motions. If you think about our key marketing or sales motions, right? We have a catalog of activities we do on a daily basis. And we categorize them based on, and what are all the top of the funnel, meaning educational, more branding, more evangelizing sort of things. And then as you go through the funnel, then we kind of hit where rubber hits the road, right? Where we are kind of more deep diving into our solutions and our products. There are several events we do for those kind of things, right? Literally going down, explaining how Azure machine learning works and how Azure works and how Office works, how Dynamics works. So you look at all this catalog of activities, and then we decide on which activities we want to go, which we think have a higher impact on Azure consumption. So that's where we do EDA that Zhijun is talking about. Through EDA, we can decide, exploratory data analysis, right? You decide, these are all the core activities have higher impact on the consumption, meaning we look at accounts that went through those activities, accounts that did not go through those activities. Right? You see through inference, you can see which KPIs have higher impact. And then we start kind of working through our correlation causation analysis based on the inference analysis. That's one way to do it. That's what we sort of typically do. And second way to do it, the mission itself tells us which activities and which combinations are working well. So we look at the both. And then, we then, based on that, we project, this is the customer journey, these are the recommendations that our sellers and marketeers would go after.
Okay, thank you.
For the feature selection, most of the time, you can just use your domain knowledge. And you can also use the hypothesis to test the feature to see if the feature is important enough. If the feature is not very important, you can just drop that feature, or you can combine some feature together as a new feature. Yeah. We don't do too much on that, but it is a way, so you can use the hypothesis to test the feature. I know there's another session that will talk about the A/B test that probably you will learn how to do this.
Question if there's time.
Sharing, I was curious to know how are you applying machine learning to score the leads? Earlier in your PowerPoint presentation, you had mentioned that you can apply. So I was curious, to the extent you can share, how does that work?
So we use machine learning. Well, let's talk about marketing leads at a high level, right? I know we have only a few minutes here. And if you look at the marketing and marketing leads, quote unquote, right? It went through a sort of a sweeping journey in the last few years. How we decide a marketing lead is a lead that we can send to our sellers, right? Marketing qualified lead, marketing automated qualified lead, highly engaged account. There's several ways we went through the journey. And today, what we use is, we use, of course, machine learning, mostly correlation and some causation, mostly correlation, and look at all the marketing activities that customer has been doing with us for the last 12 months. And then the machine decides based on, there are some criteria that we use, if our events that are, people are coming in, spending with us 2 days, a slightly higher weightage and compared to other events. And we build a feature set based on the, sort of criteria priority that Zhijun went through, the way we decide. And then, that machine will spit out every day and say, okay, these are the top 2,000 accounts that are primed for a conversation, right? And that's one model, right? That sort of gives you, sort of the highly qualified leads or highly engaged accounts that customers would be willing to talk to us. And then we have an AI bot on top of it. So the AI bot will sort of call them or email them based on the customer preference. And then it automatically prioritizes the accounts we should follow up with on a priority basis. And then those accounts, customers say, yes, we want to talk to us, or they show interest, those come to the top and others go down to the bottom. So that's an AI model that stays on top of the marketing qualified lead model that we have.
Yeah, so probably 3 or 4 years ago, we have the rule-based lead score model. It depends on what the lead has done. If the lead click a button, we give that lead 5 scores. You download a web page, it give 10 scores. But now we totally switch to the machine learning model. It is IT managed model.
Yeah, I think Steve has a question.
I think it's a tree model.
Thank you.
Yeah.
Oh,
yeah.
Yes.
Steve, go ahead.
Hello. In terms of computation running time, say that we were developing a Bayesian model with Python or PyMC3. Roughly how fast something like that, someone would be running a sample would run, say, on a regular laptop.
Did you catch the question, Zhijun?
I didn't capture that question. Can you repeat that?
Sure. I was wondering, in terms of thinking about computation speed and performance, if you've had any experience, say, running any Bayesian models, right, where you'd be doing a sampler that might take a while, say on a laptop, it might take like 20 hours, right? What the performance would be, say, with options in Azure as opposed to like a regular laptop.
Yeah, I think you asked about the performance on the Azure machine learning. You can set up a very big, very multiple nodes cluster, and you can scale up your cluster as well. So the performance will depend on your computing. Yeah.
Great. Thanks so much, everybody. We're at time. But thanks so much, Zhijun and Praveen and the entire Microsoft team for the session today. It'll be posted on the on-demand portal for the event after, so you can go back and reference it. I know there was a lot of good stuff in there. So thank you, everybody, and join us this afternoon for our second workshop. All right. Have a good lunch if you're on the East Coast. Bye.
You too. Thank you, team.
Thank you, everyone.
Bye.
Bye.